everyone, we're going to determine whether the geometric series is convergent or divergent. If it is convergent, we're going to find the sum. I find it useful to rewrite something like this with decimals as fractions. I think it's easier to see the pattern. So if I rewrite this like that, and then let's simplify our fractions. This would be 2/5, and this one would be 4 divided by 50, which is 2 divided by 25. Now, it is a geometric series, so that means it should have a common ratio. So the common ratio, the way you can find it, if you look at this, you can tell if I put this over 1, we're basically multiplying each term by -1/5. But the way to do that is you take your term you're looking at and divide it by the previous term. So if you take this term divided by 10, you get -2 divided by 10, which equals -1/5. Or we could take this term and divide it by -2. So you take 2/5 divided by -2, and this is going to give you 2/5 times 1 divided by -2. So that also gives you -1/5. And the same thing's going to happen if you do that. So our common ratio equals -1/5. Also, absolute value of -1/5 is less than 1. So that means it's convergent, and what it converges to is this. So it converges to A divided by 1 minus R. A is your first term. Sometimes they put A sub 1. If there's not a 1, that means it's the first term. So we're going to have 10 divided by 1 minus -1/5. All right, so that's really just going to be plus 1/5. All right, so this equals 10 divided by 5/5 plus 1/5, which equals 10 divided by 6/5. And then we're going to go ahead and say 10 times, instead of divide, and flip this around. So this is going to be 5 divided by 6, which gives us 50 divided by 6. Now this reduces to 25 divided by 3. So this is what our geometric series converges to. Thank you. Have a nice day. Bye-bye.